Hey guys, we're going to do page number 35 today, which is the combined gas law. Okay, so the combined gas law is exactly what it sounds like. It's a combination of Boyle's law, Charles' law, and Gay-Lussac's law. So frequently a gas sample is subject to changes in more than one variable. In such cases, all three of these equations can be combined into a single equation representing the combined gas law, which basically states that the volume of a gas sample changes inversely with its pressure and directly with its Kelvin temperature. Okay, so they take these three laws that we've already learned about and combine them into the combined gas law. And I could be wrong, but I think you guys might have talked about this in your math class. So hopefully it is familiar to you. Okay, let me zoom in a little bit. So a couple of reminders. Remember, whenever we are doing gas laws, your temperature must be in Kelvin. And if you ever hear anything about STP, standard temperature or pressure, remember standard temperature is 0 degrees Celsius and standard pressure is 1 atmosphere. And of course, if we're converting that to Kelvin, that's 273 Kelvin. Okay? All right. So let's do a couple of examples. First example, if I initially have a gas at a pressure of 12 atmospheres, so I'm going to highlight everything I'm given. So if I have a gas at a pressure of 12 atmospheres, a volume of 23 liters, a temperature of 200 Kelvin, and then I raise the pressure to 14 atmospheres and increase the temperature to 300 Kelvin, what's the new volume of the gas? Okay, you can tell that this is going to be a combined gas law problem because of what you're given. You're given pressure, you're given volume, and you're given temperature. You're given another pressure, you're given another temperature, and then you're asked to find the new volume. So this would be P1, V1, T1. This would be P2, T2, and then we're solving for V2. So let me write out the equation, because remember these equations you have to have memorized for comps, so the more you write it out, the more it will be stuck in your brain. So let's plug in everything we know. So P1 is 12 atmospheres, V1 is 23 liters, T1 is 200 Kelvin. Okay, now we're going to do the next side, which P2 is 14 atmospheres, V2 is what we're solving for, that's our variable, and then T2 on the bottom is 300 Kelvin. And it's already in Kelvin, our temperature is already in Kelvin, so we don't need to convert anything. So now we need to solve. And if you remember my little shortcut I did last time, the cross and box method, you can do the same thing. Find the three numbers that are across from each other without the variable. So not this one, because this one has a variable in it. So these three here, and you're going to multiply those three. So you're going to multiply those three, and then whatever's left over, you're going to divide. So box. So then you're going to multiply those three together, then you're going to divide by the 200 and divide by the 14. So go ahead and get out your calculator. Let's give it a try. So I'm going to go 12 times 23 times 300, hit enter. Then I'll divide by 200, enter. Divide by 14, enter. And I get 29 point blah, 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 blah. So let me write my unrounded right here. 29.5714. Dot, dot, dot. Okay, how many sig figs do I need? Looks like I have only one sig fig here and here. So how do I round this to one sig fig? I'm going to have to round it to 30. And then what are my units? Well, this is volume. The volume over here was in liters, so this one will be in liters. Okay, that's how you do it. All right. All right, this one is a U-try. I'm going to let you guys go ahead and try that. So pause the video and don't forget to convert to Kelvin. And let's see if you can plug everything in and figure that one out. So go ahead and pause the video. All right, hopefully you paused it. This is what I got. I plugged everything in. I converted to Kelvin first, and I got 2.5 atmospheres. So take a look at my work, take a look at your work, and see if they match. Okay? Okie dokie. On the back, you have some problems to do, some practice problems. There are 5 of them. Okay? So, there we go. So make sure you do all 5 practice problems, show all your work just like we did on the example, and that is it for today. Once you finish all 5 of these, take a picture, submit it in assignments.